Hi, my name is Tanishq and I'm a CSE second year student of Benin University, and today I'll be explaining the working behind insertion sort. So let's get started. So let me start off by explaining the basic working behind insertion sort. So in this algorithm, the main list is subdivided into two parts, a sorted part and an unsorted part. Now let's check out the steps that we need to follow in order to apply insertion sort to an unsorted list. So the first step says that the first element in the main list is already considered to be sorted. So now we need to select the first element of the unsorted list and then compare it to all the elements in the sorted list. If the selected element is smaller than the elements in the sorted list, all the positions of the greater elements are incremented by 1 and the selected element is placed such that all the elements in the sorted list to the left of it are smaller than it. Now we need to repeat the steps 2 to 4 until the list is completely sorted. So now let's take an unsorted list and try to sort it using insertion sort by applying the steps that we saw before. Step 1 says that the first element in the main list is already considered to be sorted. So in our case, that element is 6. Step 2 was that we need to select the first element of the unsorted list, which is 2. Now moving on to step 3, we need to compare the elements of the sorted list and unsorted list. So here we need to compare 6 with 2. Now upon comparing, we see that the element 6 is greater than 2 and so its position is incremented by 1, and as there is no element left to compare 2 with, we insert 2 in the first position and now 2 is in its correct position. So now let's repeat the steps 2 to 4 until this list is completely sorted. Repeating step 2 again, we see that the first element in the unsorted list is now 4. So we need to compare 4 with the elements 2 and 6 which are part of the sorted list. Upon comparing, we see that the element 6 is again greater than 4, so its position is incremented by 1, and when we compare 2 with 4, we see that 2 is smaller than 4 and so it stays in its position, and now we have found the correct position for the element 4. So now let's quickly apply the steps that we saw before to the remaining elements of the unsorted list. Now starting off with the number 9, we see that 9 is greater than all the elements in the sorted list and so it stays in that position and is now part of the sorted list. Now moving on to 3, we see that the elements 9, 6 and 4 are all greater than 3. So their position is incremented by 1 each, and now when we compare 3 with 2, we see that 2 is smaller than 3 and so we have found the correct position for the element 3. Now moving on to the final element, which is 7, we see that only the element 9 is greater than 7. So its position is incremented by 1 and so 7 is placed in its correct position and the list is now completely sorted. So this is the final sorted list, and let's quickly check out the pseudocode for insertion sort. Okay, so now let's check out the time complexity of insertion sort. So the best case will be when the list provided is already sorted. But even in that case, insertion sort will run the outer loop once and so it will make n comparisons, and hence the time complexity in the best case will be big O of n. Now let's check out the worst case. The worst case will be when the list provided is in descending order. In that case, it will need to make n comparisons n number of times by comparing every element with every other element. So in that case, the time complexity will be big O of n square. And the average time complexity is also big O of n square. So now let's check out some advantages insertion sort has over other sorting algorithms. So the first one is that it's relatively simple and easy to implement compared to other sorting algorithms. The second one is that it can also sort a list as it receives it. This makes it an online sorting algorithm. And the third one is that it is quite efficient for substantially sorted datasets. So basically datasets that are almost sorted. Now let's take a look at some disadvantages of insertion sort. So the first one is that it is less efficient for larger lists. So other sorting algorithms tend to outperform insertion sort when larger lists come into play. The second one is that the worst case time complexity is big O of n square. So sorting algorithms like quick sort and merge sort tend to have better worst case time complexities compared to insertion sort. So to conclude, insertion sort is one of the most basic and widely known algorithms, and even though it's not the best one or the most efficient one out there, it will still help build a basic understanding of how algorithms actually work. And that's all you need to know about insertion sort for now. So that's it for the video, and thanks for watching.